Hello everyone, welcome back. In this video, we'll be discussing about the third problem of today's weekly contest, lexicographically minimum string after removing stars. The problem states that you are given a string as it may contain any number of star characters and your task is to remove all the star characters. Now, while removing a star character, you will do the following operation. You will delete the leftmost star character first, and then among all the non-star character to its left, you will choose the one which is smallest, and if there are multiple smallest character which exist in the left, you can choose any one of them. Now notice that this is your choice, and depending on what you choose, the resulting string will differ, and hence the problem asks us to return the lexicographically smallest resulting string possible after deleting all the star characters, right? So let's take an example. Let's say this is the string and we have these two star characters, so we have to remove both the star characters. So it is given that we will start with the leftmost star character first, so it doesn't have any ambiguity that we will start with this one and we'll try to remove this one first. Now it's also clear that among all the characters in the left, you will remove a, right? Because you have to remove the smallest non-a character to its left. So now there are multiple a's here, and that's where the choices comes to us, which a to remove, and depending on what we remove, we can have different outcomes. For example, let's say while deleting this star character, you remove this a. Now while deleting this star character, you remove this a. Again, because you have to remove the smallest character, a will still be the smallest character and you will be removing a only. So if you do this, the string would become cba. So this is one of the string. Now let's say while deleting the second star, you decide to delete this a, so the string would become cab. And the other criteria is while deleting the first star, you decided to remove this a, and while deleting the second star, you decided to remove this a. In that case, the string would become acb, which is this one. So among these three, this one is the lexicographically smallest one, and hence this will be the answer. So hope the problem statement is clear. Now how to solve this? Notice the ambiguity piece. Ambiguity only comes about choosing which a to remove. It is certain that a will be removed. We just need to choose which a will be removed. Now let's think about it. Let's say you are trying to remove first a. Now if you remove first a, whatever comes after a will come in place of a in the resulting string, right? So in this case, let's assume that a was the very first character. So in that case, after removing this a, we will be exposing a character which is greater than a. Why? Because a was the smallest character in the left, right? Because as per the definition, we have to choose the smallest non-star character. So because a was the smallest character, whatever comes in place of a will be greater than equals to a, and hence whatever string we will get after removing this a will surely be lexicographically larger than what we would have with a, right? So with this logic, does it make sense to remove this a or this a? The answer is for sure not this a, because if you remove this a, c will be there, and whatever string will be formed will have c as the first character, and that will not be lexicographically larger than whatever you got with this a, right? So we kind of understand that if a is the very first character, we will not remove it for sure. Now we still have two choices, right? This one and this one. Which one to remove? The answer is again the exact same argument. Let's say you remove this a, so whatever comes in place of this a will be greater than equals to this A itself, right? And whatever string you will be forming, that string will have AC first, and after that it will have B, or a character which is greater than equals to A. Whereas if you have kept that A, that string would have A in that place, and this is surely lexicographically smaller than this one because of the definition that we will be choosing the smallest non-star character. So again, if possible, we should not remove this A from here, because if you remove this A, it will expose B, which will create a lexicographically larger string. So the choice left to us is this A. So what we are doing, we are kind of sure in every iteration we will be picking the last A or the last smallest character. Okay, so now everything is deterministic. We will pick the leftmost star, we will pick the smallest character in the left of the leftmost star, and among all, if there are multiple smallest character, we'll pick the one which occurred last, because anything before that will be yielding a lexicographically larger string or the exact same string. So we now need a data structure, like for each star, what we want what is the smallest character in the left, and among all the smallest character, which one is the last character, which occurs last in that string, right? So what we want a data structure that can help us insert an element, because you will be iterating from the left, right? So when you reach this star, you will actually have inserted all this element to your data structure. So you need a data structure that can add elements, and then when you remove this character, you will be removing one of the characters from here as well. So this data structure that you will be having should be able to remove a character as well, and finally this should be able to give us the smallest character which occurs last in the entire leftmost piece, right? So in essence we need three things: inserting an element, removing an element, and finding the largest element. Why largest element? We can like again, this largest element is definition is sort by character first and then by position, and characters should be sorted in smaller first and position should be sorted in larger first, right? So this data structure should be able to give this element efficiently, and this should be able to do these two operations as well efficiently, and you will be doing each of these operations for each star, and like you will be doing insert for n number of times, right? You will be doing remove star number of times, right? And you will be finding out largest as well, star number of times. So number of stars can be odd the order n at max, and similarly number of this operation can be also of the order n. So overall all of these operations should be efficient. You can't have a like linear data structure that will give you all of this in order n time, because that will make the complexity order n square, which is not sufficient to pass. So what is the data structure that can do all these three things? You can use priority queue, you can use set, or any ordered data structure. So in this case, if you use any of them, each of these operations is log n, so overall complexity is simply n log n, right? And this will pass the given time constraint. So I'm not showing you the pseudo code for this, because this is literally inserting the element into this data structures and finding out the largest element, and then finally removing it from your set as well. So would strongly encourage you to pause and try to code this entire thing by yourself. The only difficult piece here is defining this comparator here, and this comparator, as we discussed, should first sort by the characters and then should sort by the positions, and positions, the largest ones should come first, right? If you have any difficulty with comparator, I have a different video on comparator altogether. I can link that and you can watch that. In that video I gone over every, like starting from the basic, we have discussed about more complex comparators as well. So would link that somewhere in the description of the video. You can watch that if you face difficulty with that. So next we're looking at the code. The code is exactly what we discussed. We are using set, not priority queue, and this set will contain two things: the character and the index where this character occurs, right? And notice this set should be sorted in the sorter order of character first, and the largest index should come first. So either you define a comparator or you just make the index negative. So you want, let's say there are 3 indexes, 0, 2 and 4. So you want 4 to come first, right? But when you sort a comma 0, a comma 2 and a comma 4, a comma 0 will come first, and then a comma 2 will come, and then a comma 4 will come. So instead of this you can simply do minus, because if you just revert the sign, the largest one will now become the shortest one. So if you again sort it, this will come first, this will come second, and this will come third, and this is exactly what order you want, right? So either you can define the comparator or you can just work around with this simple trick. This trick helps in most of the cases where you have just order of numbers matter, right? So in this case what we have done is we have taken two things, one set and one vector. Again, this vector might not be required, I just taken it for simplicity. What we are doing, if the character is not star, we'll simply insert that to the set, and notice while inserting, we are inserting the character first and then the negation of the index, so that the largest index comes first in the set. Now if we got a star, we check if there is any element in the left or not. If there is no element in the left, you will not delete it, right? Now if there is an element in the left, you have to delete the smallest one which occurs last, which basically is the top element from this set. So you will just take the top element, find the index, and notice you have to now negate it as well, because the index would be negative. So actual index is the negative of that, right? So you just negate it and say that this is no longer there, you have removed it, and you will remove it from the set as well. Now finally you can simply go over all the indexes, see which one are not dead, and that you will include in your final result, and that will be the lexicographically smallest string possible after doing all these operations. So hope this is clear. If you have any doubts, feel free to post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. I will see you in the next one. Thank you.